Welcome to the project demonstration of Thermo Volt. So in this project mainly we are converting heat to electricity, and that feature will be executed with help of thermoelectric effect using Peltier plate. So which is worked on the Peltier effect, which is used to convert heat to the electricity as well as electricity to the heat. It's a kind of a transducer. So if we heat this thermoelectric plate one side and cooling the other side, then the voltage will be generated from this wires, and that will be given as input to the battery pack for charging purpose, and we can utilize the charged voltage to the inverter to convert AC to DC to AC using the inverting circuit. And the same manner we are going to use a DC to DC converter for charging of mobile phone. So DC to DC nothing but 12 volts of DC will be converted into 5 volts of DC, as the charging voltage to the battery, mobile phone battery, is a 5 volts. So that will be done with the help of this LM2596 voltage regulator. And next is a USB connector to connect that to the mobile phone charging purpose. And this one is an inverter which is used to invert the 12 volts DC to 12 volts of AC. So the output from this inverting board is 12 volts of AC, and that will be step up to the 230 volts using this step up transformer. So we are using 12 volts to 230 volts step up transformer of 3 ampere current can be handled using this transformer. So the output from the transformer is directly connected to this AC 230 volts load here. And also we are going to use a transformer which is used to charge a battery whenever the sufficient power is not available from this thermoelectric plate here. So just connect the transformer to the 230 volts AC input, and which will step down the 230 volts AC to 12 volts of AC. This is a charging circuit which will take 12 volts of AC input and provide us a 12 volts DC output to the battery pack. And the same manner, this thermoelectric plate of a Peltier plate will take this voltage which is getting from this thermoelectric plate is input to this charging circuit to the battery pack. We are using the two charging circuits. So one is to take the 12 volt 230 volts of AC input and provide us the 12 so DC output to this battery pack, and this is the charging circuit to take the thermoelectric plate output and provide that to charging of this battery pack. So here the coming to the ratings, we are using 12 volt 6 amp thermoelectric plate, and we are using 12 volts 1 amp DC battery pack. This is consists of 3 4 volt 1 amp batteries are in series, so we'll get 12 volt 1 amp DC output directly from this battery pack, that is parallelly input to the inverting circuit as well as to this DC to DC converter. So to check the generated voltage from this thermoelectric plate, we are making use of multimeter, which is continuously measuring the voltage and displaying on this multimeter screen. So to provide the heat to this one, for demonstration we are making use of our soldering iron directly, which will take heat, provide input to this thermoelectric plate. So whenever the heat was getting into the thermoelectric plate, slowly the voltage is increasing. We can observe that on the multimeter screen here. So the slowly heat was connected to the plate, so the slowly the voltage is getting increased. So in real time directly we can attach this side of the thermoelectric plate to any heating object. In real time we can use this for a silencer or any wastage burning heat coming from that burner that will be connected to this thermoelectric plate, and parallelly we should cool down this side of the plate, then only we are going to get the sufficient voltage. That's why we place the both side heat sinks. So this side heat sink for cooling purpose and this side heat sink for heating purpose. So you can see that the voltages keep on increasing as a temperature rising to this side of the Peltier plate. The voltage also will be keep on increasing. So in this manner we are going to converting the thermal power to the electricity power by using this thermoelectric effect. And coming to the utilization, next can disconnect this. So the charging time for the from the transformer, using this transformer, it will take around 3 to 4 hours to be get fully charged for the battery pack. So once the battery is fully charged, we can utilize that to the inverting circuit purpose directly, right? Okay, and coming to the DC to DC application, we are using this for mobile phone charging purpose. So the charger has got connected, right? So this one is the DC to AC application, and this one is a DC to DC application. Thank you.